So this week, we are going to sort of wrap up everything we know about inference and learn a little bit more about it as well. So in the 2 weeks prior to this, we have looked at one sample t-test, that was last week, and one proportion z-test, which was 2 weeks ago. This week, we're going to look at what happens when we have two samples that are either proportions or means. So first, let's take a look at how do we make those decisions. So when we're looking at these questions, it's best to ask ourselves three different questions about our situation or data that we're given. The first is means or proportions, and honestly, this one should be something you were already asking yourself last week. Do we have data in means, which means averages, an average height, an average length, an average length of time, or in proportions, which is either a fraction or a percent? So we should already be familiar with that, and obviously we know that we handle averages and percentages differently in our inference procedures. And then we have one sample or two, and I said be careful on this one because we're used to just one set of data that we're then comparing against what we believe should happen in a hypothesis test. So this week, we might actually have two samples. So I might have a set of data for men and a set of data for women, or something like that, where I'm trying to compare two different distributions. And again, be careful. Do I actually have two samples, or do I have one sample that I'm comparing against what we believe should be true? So this week we'll actually have two physical sets of data or not. So that's the question you have to ask yourself. And again, this will make so much more sense once we look at some examples together. But the last question is independent or paired, and this only happens if we have two mean samples. So if I have a mean of heights of men and a mean of heights of women, then I need to ask myself, okay, is that data independent or paired? Which means, are the two samples somewhat related or tied together? Or am I just looking at two measures? So the example that I just looked at, heights of men, heights of women, if I randomly selected a bunch of men and randomly selected a bunch of women, then those two sets of data are independent of one another. If I gave a pre-test, post-test situation, that's the same student taking a test, so it's the same overall ability within that student, and so I'm just calculating the difference in that student. So obviously that data is paired because those results are tied together. So that's the last question that we'll ask ourselves. And I really put together this flowchart, and again I included this in your Blackboard course as a downloadable PNG file. And this hopefully will help you to determine which test you should choose. So notice we'll kind of just go through it together. So first we have what type of data. So if we have proportions, then we obviously know that we're dealing with a z statistic, and it's a percentage. And then I ask how many samples. If it's one sample, we'll do a one proportion z-test, which we already know how to do. If you have two samples, which we'll learn in a little bit, it's just called a two proportion z-test. So it's pretty straightforward. There's nothing tricky there, and there's no other question to ask ourselves about, is data independent or paired? If we have means, then obviously that's an averages question, and we're dealing with a t statistic rather than z. How many samples? If we have one sample, we're doing a one sample t-test. We already know how to do. If we have two samples, we're going to learn this week that there are a couple of options. If it's independent, we're going to do what's called a difference of means, or two sample t-test, but to be more specific, difference of means. And then if they are paired, we're going to do a matched pairs t-test and a blocked pairs t-test, and we'll talk about the difference between those, but it has to do with observations or experiments. These two, and I just kind of ran out of room, are called mean of differences. Mean of differences test. So let's get to learning about all of this, but first let's do a little bit of practice to make sure we understand which test should be used and why. So we're going to look at this question together. And here I want to see if there's a difference in understanding measured by pre-test and post-test scores. So obviously this is going to be a test score before and after students watch this video. So obviously the question is, do you understand which test to use better now that you watch this video? So the first question I ask is means or proportions. And the answer would be means because we're looking at test scores. So I'm not saying what percent of students passed or anything like that. I could do that test and that would be a proportions test, but this is just a means test score. One sample or two, this is two samples because I have a whole set of pre-test scores and post-test scores, but here's where it gets tricky. This is paired because it's the same student. Now, we don't know how to deal with that yet, and so don't worry, I'm not asking you to do the test. I'm just saying which test should be chosen. So again, I've got t-test, I've got two samples, and they are paired. And then whether it's an observation or experiment, experiment, as we know, means that some treatment has been applied. So I should have chosen between the blocked and matched pairs, and because we had a treatment of the video, it is considered blocked pairs. Blocked pairs t-test. Let's look at another one together. This one has to do with seeing if there is a significant difference in the free throw percentages between men's and women's basketball teams' free throw percentages. Which test should I use? So again, I ask myself the question, means or proportions? Because we're dealing with percentages, that is a proportion. So data is a proportion. How many samples do I have? Well, I've got a sample of men's free throw and women's free throw percentages, and therefore I have two samples. So I've got two samples. Now the last question, independent or paired, notice up on my flow chart, I don't really need to answer that question because we never have paired data for proportions. So what test should I choose? The two proportion Z test.